Hello, 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 hello. Hello everyone. Today we shall discuss. Hello everyone. Today we shall discuss about class 11, that is the chapter units and measurement. Right. Today we'll learn about units and measurement, and you see what are the various things we'll discuss about in units and measurement. The first one we'll discuss. The first one we discuss about the units and measurement. First of all, we learn about the here you see we have taken one page and we discuss about units and measurement. You see how it is, how we are doing this one. That is, we are explaining about units and measurement, right? The first one, what we want to learn, that is units and measurement. Here see we'll discuss about units and measurements. This is units and measurements. This is for class 11. Units and measurement. This is for class 11. This is for class 11. First we learn about what are the basic things in measurement. First we learn about nature of physical laws. First one we learn about nature of physical laws. Nature of physical laws. In nature of physical laws, we have four forces we have to consider. Nature of physical laws. In nature of physical laws, we consider about four forces. Number one is gravitational force. We deal about four forces. That is, number one is gravitational force. Gravitational, gravitational force. And number two is electromagnetic force. Number two is electromagnetic force. Electromagnetic force. Electromagnetic force. And third one is nuclear force. Nuclear force. Nuclear force. And the fourth one what you deal is weak force. These are the nature of physical laws, weak force. And we learn the characteristics of these forces. What are the different characteristics? That is, we learn about relative strength. What are the relative strength of these forces? Relative strength. We learn about relative strength and what is the range. We learn about range and also place of action. And what are the place of action we learn today? Place of action. First one is gravitational force. Gravitational force, the relative strength is 10 to the power minus 38. 10 to the power minus 38. And in case of electromagnetic force, it is 10 to the power minus 2. 10 to the power minus 2. In case of nuclear force, it is 1. Nuclear force. And in weak force, we deal about 10 to the power minus 13. 10 to the power. This is the relative strength. And we find the range. In case of gravitational force, the range is infinity. In case of gravitational force, the range is infinity. And in case of electromagnetic force, it is also infinity. In case of electromagnetic force, it is also infinity. In the case of nuclear force, it is within 10 to the power minus 15 meter. Nucleus, within nucleus or nucleus, or 10 to the power minus 15 meter, or you can say within nucleus. Nuclear force is acting within nucleus, within nucleus. And the fourth one, that is weak force. Weak force is within nucleus, that is also within 10 to the power minus 18 meter, 10 to the power minus 18 meter. It is also within nucleus, within nucleus. These are the various forces we deal about. There is nature of physical laws: gravitational force, electromagnetic force, nuclear force, and weak force. And place of action we will learn about gravitational force. The place of action is all objects in the universe. Place of action is all objects in universe. All objects is applicable for all objects in universe. That is gravitational force. And the second one is electromagnetic force. Electromagnetic force is for charged particles. Charged particles. It is for charged. Electromagnetic is for charged particles. And the third one, there is nuclear force. Nuclear force is for nuclear force within the nucleus. That is, place of action is within nucleus. Within the nucleus. Within nucleus. And the last one, what we call it, is weak force. And weak force in applicable in elementary particles. It is applicable in elementary particles only. Elementary particles. Elementary particles only. These are the various characteristics we learn about, and this is the nature of physical laws. Now we learn about the physical quantity and its measurement. Physical quantity, what are the meaning of physical quantities? Physical quantities are those quantities which can be measured, right? Physical quantities are those quantities which can be measured. For example, length can be measured, time can be measured, and mass can be measured. Length can be measured in terms of meters, time can be measured in second, and mass can be measured in kilogram, right? In this way, we can measure this physical quantity, right? Now we learn about units of measurement. In units of measurement, we have very important. There is importance of units also. How to write? Suppose I would now want to write length. Length can be written 10 meter. This is numerical value, and this is the unit of that quantity, right? For time, I'm writing 5 seconds. That is, this is the numerical value, and second is the unit. In for mass, it is 5 kg. 5 is the numerical value, and kg is the unit of mass. In this way, we write the various units. There are some units also, and there are some unitless quantity also. We have some unitless quantity, that means there is no unitless quantity. There are unitless quantity also, and these unitless quantities can be written as solubility. Solubility has no unit. Solubility has no unit, right? In this way, we can find some unitless quantity also. Besides that, we have two types of units. What we call units can be divided into two parts. What we call first one is the fundamental unit. What we call it as the fundamental unit. Fundamental unit. And the second one we call it as derived unit. What is the meaning of that? Derived units. Now we learn about fundamental units. Fundamental unit is three: the length, mass, and time are fundamental units. And derived units is dependent on these fundamental units. For example, area or volume or force, acceleration. For this unit, we'll get acceleration. We find the units of acceleration, we find the unit of force, unit of volume, unit of area. This will be dependent on fundamental units, right? And suppose the unit of area is liter length square, volume is L cube, acceleration is meter per second square, right? Meter per second square. And see, meter and second is dependent on fundamental. These are derived unit and these are fundamental unit. Fundamental unit are independent unit, but derived unit are dependent on fundamental unit, right? This is the main difference between fundamental units and derived units. Now we have different systems of fundamental units. Now we learned about different systems of fundamental units. Different what the different systems of fundamental units that we are going to learn. Different systems of fundamental units. Different systems of fundamental units. Different systems of fundamental units. Systems of fundamental unit. Of fundamental unit. Actually, we have three systems. One is what we call as CGS system, CGS system. CGS is centimeter, and G is gram, and S is second. And another one is what we call it as MKS system. MKS system. In MKS system, we got it as meter. The length is measured in meter, and the mass is measured in kilogram. It is measured in kilogram, and time is measured in second. This is MKS system. And the third one is FPS system. FPS system. The length is measured in foot, and the mass is measured in pound. Pound, pound, and the time is measured in second. These are the different systems of units. Besides that, we have SI system, and this is most important for SI system or international system of units. This is international system of units. System of units. In international system of units, we have seven fundamental units and two supplementary units. These are length. Length is measured in meter, right? Length is measured in meter, and mass is measured in kilogram. Time is measured in second. Besides that, there are other also. The temperature is there. Temperature. The SI unit of temperature is Kelvin. This is capital K. And there is electric current. Electric current. The other physical quantities are electric current. We have seven fundamental SI units. Electric current is measured in ampere. It is measured in ampere. Electric current. Besides that, we have luminous intensity. Luminous intensity. We have luminous intensity, and luminous intensity can be measured as candela, or we write it as CD, that is candela. And next one is amount of substances. Amount of substance. Of substance. Amount of substance can be measured in mole. Amount of substance can be measured in mole. These are the seven fundamental unit of SI system. Number one, this is mass. This is time. This is temperature. This is electric current, luminous intensity, and amount of substance. These are fundamental units. Besides that, we have these are fundamental units. We have supplementary units also. There are seven fundamental units in SI system. Fundamental units. These are fundamental units. Besides that, we have two supplementary units. We have two supplementary units, and these are number one is what we call it as now one is angle. An angle is measured in radian. We know that angle is measured in radian. And radian is the unit of circular system. And number two, we know it as solid angle. This is solid angle. Solid angle. And solid angle can be measured in the unit of steradian. Steradian, or we call it as SR. Steradian. Angle is measured in radian and solid angle is measured in steradian. These are two supplementary units. And these are seven fundamental units: length, mass, time, temperature, electric current, luminous intensity, and amount of substance, that is mole. Right? These are different things, and now we learn about some definition of fundamental units. There are various definitions of length. There is definitions of mass, definitions of time, temperature, electric current, luminous intensity, amount of substance. There are different definitions of all these things. Meter can be defined. In these, all these we can define: kilogram, second, ampere, candela, mole. All can be defined. Radian can be also defined, and steradian we can all define all the system, all the units. There are we can define seven fundamental units and two supplementary units also. Now we'll learn about multiples and sum multiples of units. This is very important for us. This is multiples and sum multiples of units. We learn this one. There is multiples and sum multiples of units. What are these? These are multiples and sum multiples of units. We'll learn is this one. Multiples and sum multiples of units. Multiples and sum multiples of units and sub multiples and sub multiples of units. Number one, what we call it as atto. We know all these things. That is, it is prefix. This is prefix. This is symbol, and this is the multiplication factor. This is multiplication factor. Multiplication factor. The number one, what we call is atto. Atto, the symbol is A, right? And multiplication factor is 10 to the power minus 18, 10 to the power minus 18. Number two is femto. FEM TO, and the symbol is F, and it is 10 to the power minus 15, 10 to the power minus 15. And the next one is atto, femto, pico. Next one is pico, 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 and the symbol is P, and the unit is 10 to the minus 12, 10 to the power minus 12. There is a difference of 3 units. Number 4 is after pico, it is nano. Nano, the symbol is small n, and it can be 10 to the power minus 9, 10 to the power minus 9. And the fifth one, we call it as micro. Micro, this is micro. And you know the symbol of micro is like this. This is the symbol of micro, and it is 10 to the power minus 6. 10 to the power minus 6 in micro. And 7. After that, micro, it is milli. And milli is milli, and the unit is m. Symbol is m, and milli, and it is 10 to the power minus 3. 10 to the power minus 3 multiplication factor. And after milli, it is kilo. It is kilo, and the symbol for kilo is K, and the multiplication factor is 10 to the power 3. We know that it is 10 to the power 3. After kilo, we got it as mega, mega, and mega is the symbol is capital M, and it is 10 to the power 6. Mega is 10 to the power 6. After that, it is giga. We know that it is GIGA, giga, and it is represented by capital G, 10 to the power 9, 10 to the power 9. And the next one, after giga, we got it as tera, 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 that is capital T, and it is 10 to the power 10 to the power 12. 12, this is in capital letter. And number 11, what we got it as pita, PTA pita, and we call it as capital P, and it is 10 to the power 15, 10 to the power 15. And the last one is exa, EXA, and its capital letter is represented by capital E, and is 10 to the power 18, 10 to the power 18. Here you see, we started from 10 to the minus 18, minus 15, minus 12, minus, there is difference of 3 units in all these things, right? These are the various multiples and sum multiples of units you have to remember, right? Atto, femto, pico, nano, micro, milli, kilo, mega, giga, tera, peta, and exa. These are the few things. Besides that, we have some guidelines, international guidelines for writing symbol of units. How to write the different symbol of unit, that is also important. So we learn about the various international guidelines for writing symbol of units. These are the international guidelines, international, international guidelines, international guidelines for international guidelines writing writing symbol of units, for writing symbol of units. These are various international guidelines for writing symbol of units. So to write different symbol of units in this way, for example, We write meter, we write as small m, gram as small g, and time as second. In this way, we have to write in small letters. This is the first. And the second one, we can write in all the letters are write in Roman, not in italic. We write the letters in Roman, right? In unit, we write it in Roman. And the third one is when there are scientists, we write it as Newton for capital N, Newton, and ampere for capital A. These are name of scientist. Ampere is the unit of current. Pascal, PA, is the unit of pressure. We know these all these things. PA, Joule, Kelvin, we write in capital letter. But whenever we write in small letter, you have to write the whole thing. That is Newton is in this way. You have to write Newton, not capital A. In small letter, you can write is Newton, or Joule. You can write Joule, or you can write Pascal, PASKL. In this way, you can. This is the exact way of writing. This is the international guidelines for writing symbol of units, right? Beside that, we can write in this way. There is 150 gram. We cannot write 150 grams. We cannot write. This is the correct way. This is the wrong way, right? In this way, we can write all these things. Beside that, we can write kilogram as kg, but we cannot write kg and full stop. We cannot write this one. This is the wrong way, and this is the right way of writing units. And the next one is in temperature, we can write degree centigrade, we can write degree Fahrenheit, but in case of Kelvin, we write only Kelvin, not degree. This is the correct way of writing temperatures. And number seven, we can treat as that we know that 1 meter into 1 meter or meter into meter is meter square, or kg into kg is kg square. This is the perfect way or right way to write the units. And the next one is we write, suppose we are writing Newton meter, then you have to write n hyphen meter. We write in this way, the Newton meter, right? And sometimes we write it in hyphen also. That is in this way, that is joule per second can be written as joule per second, or you can write it as joule per second in this way. These are the perfect way of writing the various units, right? Beside that, we can write another thing in right, that the meter per second square. You can write meter per second square, or you can write meter is the minus. These are the various ways in which you can write the different units, and these are the international guidelines for writing symbol of units. Now we'll learn another thing, that is the most important thing is this one, and that is dimension of physical quantity. We learned the physical dimension of physical quantity. Dimension. What is the meaning of dimension? That I am going to tell you this one. What is the meaning of dimension? When any quantity, physical quantity can be represented as length can be represented as capital L. Mass can be represented as capital M. Time can be represented as capital T, and temperature can be represented as temperature can be represented as either theta or K. These are the dimension. We can find the various dimension. For example, we are finding the dimension of small one, that is velocity. If first one, we have to learn the formula. Velocity equal to distance by time. We know that velocity equal to displacement by time. It is displacement by time. This is the formula. And displacement can be written as this is a length, therefore it is L, and it is T, therefore the dimensional velocity is L, T to the power minus 1. In this way, you have to find the various dimensions, right? And suppose the mass can be written as with mass, the dimension of mass is only capital M, right? In this way, you can find all the, suppose area. Number three, third, you find the area of dimension. And area, we know that area is the L square. L square. This is the unit because it is length into length is the area. And if you write the volume, that volume can be written as L cube. Volume. because it is length, it is length into breadth into height. Therefore, you can write it as L cube, that is for volume. If you write velocity, if you write density, we know that density equal to mass by volume. Density is equal to mass by volume. You have to know the formula, only then you can write the dimension. Density equal to mass by volume. Mass can be represented by capital M and volume can be represented by L cube. Therefore, we can write M L to the power minus 3. These are the way in which we can find the dimension of anything. We can find acceleration also. Acceleration. We have to find the formula acceleration equal to what is that acceleration? Acceleration is uh, change in velocity by time. Change in velocity by time. That is the acceleration by time. And change in what is the unit of change in velocity? Change in velocity is meter per second. So we can write as meter per second t to the power minus 1 and time is t. Therefore, we can write it as L t to the power minus 2. This is the unit of dimension of acceleration. L t to the power minus 2. If you want to find the force, we know that force equal to mass into acceleration. Force equal to mass into acceleration. What is mass? Mass is capital M and acceleration is m l t to the power minus 2. This is the dimension of force. We can find the dimension of pressure also. If we have to know the formula, pressure equal to force by area. Force by area. Force is this one m l t to the power minus 2 and area is l is square. Therefore, we are getting m L to the power minus 1 t to the power minus 2. This is the dimension of pressure. The dimension of pressure is m L to the power minus 1 t to the power minus 2. And if we write the power, suppose you want to find the dimension of power. Power, we know the power formula for power is work done by time taken, right? Before that, we will learn about power, right? This is work, right? And 9 is work, suppose. We want to find work. After that, we will find about power, work. What is the work? Work is force into displacement. That is work. And we find the force of force as this one. That is this one. M L t to the power minus 2 and displacement can be written as L. Therefore, the work is m L square t to the power minus 2. This is for work m L square t to the power minus 2. That is work or energy. And power is work done by time taken. Work done by time taken. Work done is m L square t to the power minus 2 and time taken is capital T. Then we can write as m L square t to the power minus 3. This is the dimension of power m L square t to the power minus 3. In this way, you can find the various momentum, all these things. There are various we can find all the dimensions. For example, we can find dimension of momentum. We can find dimension of impulse of force, moment of force, angle, solid angle. There are various dimensions we can find out from the formulas. Surface tension, coefficient of viscosity, moment of inertia, radius of gyration, angular momentum, stress, strain, modulus of elasticity, frequency, Poisson's ratio, temperature, specific heat, latent heat, thermal capacity, time period, electric current, electric charge, specific gravity, gravitational potential, gravitational intensity, thermal conductivity, velocity gradient, temperature gradient, electric potential, electric field intensity, current density, electric resistance, capacitance, Stefan's constant, electric dipole moment, magnetic dipole moment, magnetic pole strength, self-inductance, electrical resistivity, magnetic flux density, magnetic flux, gravitational constant, molar gas constant, Boltzmann constant, entropy, torque. We can find all these various types of dimensions by formula, right? These are the different things we can find out, and in the last end we can find out a dimensional analysis. In dimensional analysis you can find whether a particular formula is correct or not. We can find the we by dimensional analysis. Let us find the dimensional analysis of any dimensional analysis. In dimensional analysis, what we'll find, dimensional analysis is just dimensional analysis. In dimensional analysis, we can find out whether a particular formula is correct or not. How to find in dimensional analysis? For example, I want to find a is equal to ut plus half at square. A is equal to ut plus half at square. A t square. We find the dimension. The dimension of left hand side. The dimension of left hand side is s S means distance, it is L. Let us find the dimension of right hand side. Dimension of right hand side, if I want to find, that is, it is ut, u into t plus half a t square, half a t square. U means for what? Velocity. U means velocity is meter per second or m by t. And this is also t. This is meter per second, that means length. A meter per second means length per unit time, and t is capital T, plus half. Half is a number, therefore there is no dimension for number. And acceleration is, what is the unit acceleration? Meter per second square. Meter means length, and second square means t square. And here see, time is t square also. Then d square, that means we are getting L plus L, that is L. Therefore, the dimension of left hand right hand side is also L. Therefore, since the dimension of left hand side is equal to dimension of right hand side, thereby you can say that A is equal to ut plus half t square is correct. Ut plus half at square is correct. In this way, we can find whether a formula is correct or not by dimensional analysis. Right? Therefore, A is equal to ut plus half t square is correct. There is some limitations of dimensional analysis. We cannot find this half. We cannot find the constant. These are the limitations of dimension. We cannot find this half or constant. But we can find if the dimension of left hand side and right hand side is equal, then you can say the formula is correct, right? But we cannot find the constant value, that is half. We cannot find it by dimensional analysis, and this is the limitation of dimensional analysis, right? This can be found out whether is some. These are the limitations. Now we'll learn about measurement of length, mass, and time. In the measurement of length, mass, and time, there are two methods. One is direct method, another is indirect method. We learn about both the things. After that, we learn another thing. Let us find the next thing, that is a measurement of length, mass, and time. Measurement of length, mass, and time. Measurement of length, mass, and time. Mass and time. Actually, there are two methods to finding the length, mass, and time. One what we call is direct method, and another one we call is indirect method. This is the direct method, and there is another method, that is indirect method. In direct method, you can find the different distance, mass, and time also. These are the two methods by which you can find the length, mass, and time. In direct method, what we use, number one is ordinary scale. We use ordinary scale to find length. Or number two, we can use also vernier scale to measure the length. Or you can use screw gauge. Screw gauge. These are the methods by which we can measure the distance with ordinary scale, vernier scale, and screw gauge. And in screw gauge, and there is another instrument, that is what we call it as spirometer. SPHE or spirometer. In direct method, we use all these instruments. But in case of indirect method, what we use is reflection and echo method. In indirect method, we use reflection and echo method. Reflection and echo method. This is the first method. And second method, what we remember is or use is sonar. SONAR. Sonar means sound navigation and ranging. Navigation, Sound navigation and ranging. Sound navigation and ranging. And the third one, what we know is radar, radio detection and ranging. Radar, radio detection and ranging. Detection, radio detection and ranging. And radio detection and ranging. These are the indirect method by which we measure the different things, right? And we can measure the mass also. We can measure the time also, right? These are the various things we can use in measurement. In direct method, we use ordinary scale for measuring length, vernier scale, screw gauge, and spirometer. And in case of indirect method, use reflection and echo method, sonar, sound and navigation and ranging, and radar, radio detection and ranging for measuring length. And for measuring mass, we know that for measuring, this is for length, measurement of length. This is for measurement of length. If you want to measure mass of an object, then mass of an object can be measured with common balance, right? Mass can measured with common balance. Mass can be measured with common balance, and weight can be measured with weight. These are the various things. Weight can be measured with spring balance or weighing balance, spring balance. Mass can be weight can be measured by weighing balance, or we can just say it as spring balance. And sometimes we measure the mass of atoms and molecules. To measure of atoms, mass of atoms and molecules, we use mass spectrometer. We use spectrometer, spectrometer. To measure mass of atoms and molecules, we use mass spectrometer. For time measurement, we use quartz clocks. This is for measuring mass. And for measuring time, we use for measuring time we use clocks, quartz clock, or you can say clock only, right? For measuring time. And in case of there are other methods to measure time also. These are the various method measurement of time. The one is remote sensing. We can measure time by remote sensing. It is remote sensing you can use for measurement of time. Number two, we can use GIS or geographic information system. That is GIS, geographic information system, geographic information system, information system, geographic information system. And the third one, what we call it as global positioning system, GPS, that is global positioning system, global positioning system. These are the various ways we can measure these things. And for measuring, we use the cesium clock also. Sometimes we use cesium clock. Sometimes you use cesium clock to measure time. Sometimes you use quartz clock or cesium clock. And these are some of the ways in which measure, that is the remote sensing, geographic information geographic information system, and global positioning system. We use this one also, right? And besides that, we use carbon dating to find the date of anything. We use carbon dating also. This is the method of carbon dating to find the exact date, or uh, age of earth we can find by carbon dating, age of earth, right? In this way, these are the different things we have remembered or discussed. In the next phase we will discuss, in the next video we'll discuss about the various methods, that is how to measure length with scale or vernier scale or screw gauge and speedometer. Will discuss in the next video. And in the next video we will also discuss about reflection echo method, sonar method, and radar method. Thank you everybody for watching this video. Thank you.